Good morning, eighth graders. So we are going to be working on a little activity throughout this week, weather maps, air masses, and fronts. So essentially what we're going to be doing is we are going to be taking a peek at different weather maps and start to identify what sort of weather is one specific area receiving, what could that area receive in the next day or two, things like that. We're going to be focusing in on the continental US, so all of these maps are going to look similar to what is on the screen in front of you. But let's do a little bit of review and then we'll jump into some of the actual predictions. So what is an air mass? Well, we know that an air mass is a huge body of air that has similar temperature, humidity, and also air pressure at any given height. So whether it is all the way down here at the surface to 15 kilometers up into the troposphere, it should have the same temperature, humidity, and air pressure. So scientists classify these air masses according to their temperature and their humidity. Okay, so air pressure isn't taken into consideration with like identifying the air masses, but the temperature and the humidity is. This is where we get our Arctic, our polar maritime, our polar continental, things like that. As we know, in the continental US, the air masses typically push from west to east. Now, sometimes, yes, you can get a really weird one because we have jet streams that go from north to south or south to north, sort of a thing. But for the most part, barring no jet streams, we are moving from west to east. Okay. Where these air masses come together is where we have our weather fronts. Okay, we've talked about this last week, but weather fronts are the storms and changing weather that develops. Okay, so we either get cold fronts, warm fronts, stationary fronts, or occluded fronts. So it's kind of all what air masses are moving in, which ones are moving out, at what speed are we moving, so on and so forth. Okay, so how does the cold weather front form? Well, we have cold air, which is very, very dense. Remember, cold air is sinking because it's lost that oomph. Okay, so it's dense. Warm air is less dense, so it's starting to rise. When rapidly moving cold air runs into slow moving warm air, the dense cool air kind of slides underneath the lighter warm air. And pushes that warmer air up. Okay, so you can kind of see that here in the diagram. You have this cold front that's moving in, you have this warm air that's starting to kind of be pushed up and away. So because the air is rising so quickly, tall cumulonimbus clouds often form. So this is where we get our big thunder clouds, that sort of a thing. As a result, we tend to get a lot of heavy rain, thunderstorms, or snow, depending on how cold the cold front is, and all of that. After the cold front passes, the weather tends to be a little bit on the cooler side. So these fronts move through fairly quickly. We had a cold front move in just yesterday. So I am recording this on April, what is it, the 14th? Something like that. Oh no, else let's check our, yes, Monday, April 14th. So yesterday, the morning was a little drizzly, but it was a pretty nice day. By the evening, however, around that 7 o'clock hour, we had some rainstorms move through. Not big ones, but we had some rainstorms move through, and now today it's going to be a little bit cooler. Yesterday, I think our high was like 65. Today, I think we're looking at a high of like 55. So yeah, but they tend to move through quickly. I think we're supposed to bounce back up by Wednesday. I don't know. We'll see. So cold fronts tend to bring clouds, rain, snow if it's cold enough, thunderstorms. But the skies clear very, very quickly. Cool air tends to move just a little bit quicker just because of how dense it is. It's easier to kind of push it along. So some of the symbols you should be aware of when we're thinking cold fronts. Now, warm fronts, on the other hand, this is where warm air masses take over a slower moving cold air mass. Cold air is denser again, so remember it sinks towards the bottom. So you have this cold air and this warm air mass coming in quickly, and because it's warm, it tends to rise. If the warm air mass is humid, okay, so if it has a lot of moisture within its air mass, we are looking at light rain or snowfall along the front. If the warm air is dry, you get some scattered clouds to form, just because if there's not enough moisture to super duper condense and saturate out, you're just going to condense. Because warm air moves slower. Okay, again, there's less to it to be able to kind of push it along. It may tend to be kind of rainy and cloudy for several days. So this will be a long, steady rain. All of that. But after the front passes along, the weather is likely to be warm and humid. So maybe not sticky depending on the time of year, but more humid than it was. Warm and cold are relative terms. It's all going to depend on kind of where you're at within your season. So warm and cold might mean something completely different to those in the south than it does to us up here. So that. If the air is humid, remember you're going to get a lot of rain or snow, long and continuous. If the air is dry, you're going to get scattered clouds, followed by quote unquote warm weather. Again, relative. Warm weather in our winter maybe means that it's above 0 versus warm weather in our summer means that it is going to be sticky and 100 degrees. Okay. Stationary fronts. This is where you have a cold air mass and a warm air mass that meet and neither want to move out of that vicinity. So like this is showing you have this cold air mass and this warm air mass and they're going toward each other. They're not wanting to move. So that's where you get this every other sort of front line. So the weather, where the warm and the cold air meet, water vapor in the warm air is going to condense into rain, snow, fog, or clouds. Oh my goodness. It's like as soon as I put a microphone in front of me, I'm going to start yawning. Again, it's going to depend on how much humidity is within that warm air to determine how much stuff truly evolves. You should always see some sort of cloud formation just because warm air is always going to hold just a little bit more water or moisture than cold air. If it remains stalled over an area, it may bring many, many, many days of clouds and precipitation. This is an example. So like when we are always concerned in the winter about the amount of snow that we're going to get. How many feet of snow at a time or inches? Typically, if we are getting dumped on with snow, it is because of a stationary front. We're just stuck. And that happens often because you have to remember we have that jet stream that kind of comes down with all this Arctic air meeting the warmer air. And because it's coming south, it just kind of sits here. So depending on where we're at in that jet stream. So, just kind of what happens. So stationary fronts, you tend to get a lot of rain, snow, fog, clouds, and this sometimes lasts for days. So just something to be aware of with those. Occluded fronts. This is where a warm air mass is caught between two cooler air masses. So you can see we have this really big cold air mass that came in rather quickly, more than likely, meeting a slightly slower cool air mass that's just trying to work its way out. But in between that, you had a warm air mass that just got sandwiched and it's stuck. That's why you get both warm and cool air front diagram. So this is the most complex situation because warm air is kind of caught between the two. It's like an Oreo cookie. the denser cooler air moves underneath the less dense warm air mass and pushes that warm air upward. So that warm air now is not only just being sandwiched by cold air, but now it's starting to meet the top of the troposphere, which is also really cold. That poor warm air mass, it doesn't stand a chance. The two cooler air masses meet in the middle and may mix a little bit. The temperature near the ground is going to become cooler. The warm air mass is occluded or cut off from the surface. So as the warm air cools and its water vapor condenses, the air may turn cloudy, and rain or snow may fall after the occluded front passes. There's a cool, clear weather day for a couple days. It again just depends on how quickly the next mass is moving in. So, remember, cool and warm is relative to where you are and in what seasons. So the weather that tends to come with occluded, it would be rain or snow. Isobars. So you saw on the very front page, this picture essentially. We have to be aware that meteorologists are tracking not just the humidity and the temperature, but they're also tracking the pressure. So where we have that low pressure where you have the air that's kind of being sucked upward versus the high pressure where it's being kind of pulled down. And the way that they kind of measure these things is almost like the rings of a tree. We call these rings, however, isobars. There are isotherms, so therm like thermometer, we're looking at temperatures. Isobars, however, we are looking at the pressure. So these curved lines, so little like rings on a tree, they kind of like connect the dots around weather stations as far as keeping all the likes with the likes. So everything here in the low pressure like circle is going to be the lowest pressure period. And then it gets slightly larger, but these all have the same sort of pressure and so on and so forth. Kind of like if you think of a jawbreaker, okay? You can't just have like a white center and then you have like a half blue, half red sort of a like outside coating. It has to be all blue or all red, and then the next color and the next color. You can't just like pick and choose what colors you're gonna have as far as like the layer goes. So these are curved lines on a map that show areas of equal air pressure throughout, okay? So obviously, if this is all the super low pressure, this is all the super high pressure. So areas of differing pressure causes changes in the weather. We've already kind of sort of talked about this, how high pressure systems bring happy sort of weather versus low pressure systems kind of make us go, I want to just stay inside, I don't want to go out and do anything, that sort of a thing. So areas of differing pressures change in the weather, but then the wind moves from areas of high pressure to low pressure. This is the example of like your grown-up saying, close the fridge door, you're letting all the cold air out, but really the interior of your fridge is at a much lower pressure than your exterior pressure outside of the fridge. So it's actually all that warm air trying to go into the cool air, or where the cool air is. So we move from highs to lows. Areas where the isobars get really, really close together, where there's not a lot of difference, but there's enough to be noticeable. So especially around our low pressure systems are areas where where there is the greatest amount of wind speed. So this is where you're going to see an increase in wind versus the further you get out here, especially here, it's going to be super duper calm here as well. It's not going to be a lot of change, so that the air is just able to just kind of flow nicely. Areas where the isobars are further apart, the more calm. We just talked about that. Okay, so just a quick little reminder, high pressure systems is where air is sinking slowly down. It's near the ground. It spreads out towards the areas of low pressure. Usually you see a large system that changes very slowly. So this weather is kind of dry, it's clear, it's that happy weather. I want to be outside, I want to be working and things like that out there. So high pressure systems versus our low pressure systems. This is where our air is rising so that it has a lower pressure than the air around it. The air at the center is cooled as it goes up. Oh my gosh. I'm so sorry. It goes up, it cools, it condenses, so this brings on a lot of clouds, rain, and wind because you have that changing in pressure. So, if we were to look at a map like this, view the map and answer the questions. What you get is a lot of questions of what is to come. So let's look, okay? So the first question is, in which direction is the cold front moving and how do you know? So first of all, we have to locate our cool front. We've been experiencing this entire lecture for the last 16 minutes, okay? So this is our cool front, okay? It's blue, it's cold, it has the little icicles, things like that. Which direction is it moving? Well, it's moving towards the east, because remember where our symbols are, whether it is the icicles, the suns, whatever you want to call it, they are pointing in the direction that it is moving. So this air mass essentially is moving southeast east, okay? Depending on whether you're up here or down here. Okay, number 2, what type of weather do you expect near the high pressure systems? What sort of weather should we expect? Well, we should expect some clear, dry weather. Again, dry, relative. But there shouldn't be a lot of precipitation occurring. There might be a lot of humidity, but there may not be a lot of precipitation. And finally, what type of front is near the northeast? So the northeast is up here, okay? And what do we call this one? That's our stationary front, okay? So those are the sorts of things on how we're like reading this map. Now, eventually, we'll start getting into some complex stuff, but this is more so if you want to go into more of the meteorological side of science. So, but they're really easy to read if you don't get intimidated by it. So please don't get intimidated. Work with me for a second. So, use the key to determine the type of precipitation occurring in the US. So the key is located here. So we have rain, rain with thunderstorms, mixed precipitation, meaning that we get a little bit of rain, a little bit of snow, heavy rain, possible flash flooding, severe thunderstorms possible, meaning that maybe there's tornado works, that sort of a thing. And then freezing rain possible, meaning that it's just cold enough to start freezing it, but not cold enough to keep it snow. Okay, so we got to look at that. So you can see moving up here, it's all white, meaning snow. Down here is that mixed precipitation, and you can kind of assume that if you have snow up here and thunderstorms down here. So mixed precipitation. This is green with the hashes in it, so that means that it is rain with thunderstorms, just a little bit more in your face. This is our severe watch, which also goes with our heavy rains and flash flooding, all that. And then you got a little bit of just regular rain here and along the East Coast. Okay, not terrible, not terrible. So, do you expect the rain in Georgia to be a quick passing storm, or should it last for a day or two? So what's really hard to see is that Georgia is right here. Okay, so we're on the verge of, this is a cold pressure or a cold front, but this is a stationary front. So in Georgia overall, we're probably expecting a few days of kind of icky weather. Maybe not thunderstorm sort of scariness, but like you're going to see some precipitation for a while. 3, which direction is the cold front in South Dakota and Wyoming moving, and how do you know? So we have South Dakota here, Wyoming here. We have a cold front, okay, and it is for the most part moving south. 10 bucks says there's a jet stream going through there. What type of precipitation is the cold front bringing to Wyoming, South Dakota, and Mississippi? So Wyoming, South Dakota, we have a lot of snow. Mississippi, which is right here, got a lot of rain. Why they care about Mississippi? Who knows? I think that was a misprint. So, because my answer key says just snow. Mississippi doesn't have snow. We have Montana. We have Minnesota is probably what they meant. Wisconsin, Colorado, we're getting a lot of snow in these regions. Okay? So, also, make sure you know your states, unlike this person. Final one, I just wanted to give you a little more practice. So, view the map and answer the questions. So, which direction is the warm front moving? Okay, warm front, remember we're looking for the suns, the red, because that's what's going on. Here, the direction it's moving is north. The symbols point in the direction they're moving. What type of weather would you expect in the western United States? Well, we have a high pressure system. The isobars are fairly spread apart. So we're looking at dry, clear, not much for wind. What type of weather would you expect near the Great Lakes? So this is the Great Lakes, and we have a low pressure system, so that tends to bring some precipitation, a lot of winds. So rain, snow, or clouds, depending on the temperature and humidity. Okay. Identify the area with high wind speeds. Well, remember, it's where the isobars are really close together, so it's going to be around this low pressure system. Identify the area where the winds are really calm. Basically anywhere here in the western portion of the United States, you have a lot of distance between your isobars. And then which direction is the wind blowing? So this one could be tricky, but you have to think overall. For the continental US, remember, we are moving from high pressure systems to low pressure systems. And for the most part, it's going to be moving from west to east. Okay, but in this case, yes, we are moving from high to low, which means it is west to east. Okay, now I could ask you where, like, if we are looking at Maine right now, what should the weather be like in a couple of days? Well, that warm front's going to pass through, so it should be on the relatively warm side, but you also have this low pressure system that's moving through, so there might be warm with some high winds, things like that. So keep that in mind. You are going to use this knowledge and prior knowledge that we've gone over in class in order to work with some of these maps and identify some of the things that are going on. Take your time. There's multiple days for this. Yeah, awesome. If you have any questions, reach out to your teachers. We're here to help. Yeah, but you guys got this. You got this. Awesome. Thank you, 8th graders.